Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we will look at basic circuits. As we begin to look at how we're going to put circuits together now, I'm going to look at go over a couple of the basic elements of circuits. Now, one of the things we need is some source of power, and that could be a battery, or it could be some other source, such as getting the power from your electrical outlet, maybe going through a transformer to change the voltage, also maybe changing it from AC to DC. And in our case, we're going to be working mainly with DC or direct current. And direct current, the voltage doesn't change. So if I've got it and it's this is the voltage, and say that's 5 volts, it's going to stay 5 volts the whole time. Where what we get out of the wall socket is AC, or alternating current, and that is a voltage and a current that goes high and low. It's a sine wave or an alternating wave. So we're going to be working with direct current, and for purposes of the tutorial, we'll think of maybe it's a battery. The symbol, the electrical symbol we're going to see for the battery looks something like that, or sometimes you'll see multiple lines, and the long line is the positive side and the short line is the negative side. So that's our symbol for a battery. The next thing we're going to look at is a resistor, and a resistor has a symbol that looks something like this. The battery, we measure its potential or its power with, power is not the correct word, its strength in volts. And resistor, we measure its resistance in ohms. And the symbol we use is the omega symbol for ohms. Where voltage is the potential to do work or the power of this electrical circuit, resistance is the opposition to current flow, to electricity. And the battery is trying to cause a current to flow from positive to negative. Now, if you take physics, what you'll find out is we really know that the current or the electrons flow from the negative to the positive. But years ago, when they were developing the electrical circuits and the theories of electricity, they thought that the current flowed from positive to negative. And we still, from a standpoint of looking at the circuits, we think of it that way. So the current we represent typically with an I, V for volts, and the omega for ohms, or sometimes we use, ohms are the units, R for resistance. And what we find is that the higher the resistance, the smaller the current flow. The lower the resistance, the bigger the current flow. And you can think of it in terms of water, and the bigger the opening in the valve, the more water comes through. The smaller the opening, the less water. Smaller opening would be more resistance. Bigger opening, less resistance. And of course, this is not really an electrical class set that we're going to go through all of the theory, but since we've got a voltage here, and the only other thing we've got in the circuit is the resistor, then the voltage across the battery is going to have to be the same as the resistor. So if it's 5 volts across the battery, in this case it would be 5 volts across the resistor. And we've got a couple of equations we have to look at. First of all, one of those equations is the standard voltage equation, which is V is equal to IR. So the voltage across this resistor is equal to the current times the resistance. Now, we can play algebra on it and solve for anything we want. If we need the current, it's the voltage over the resistance. So, and if we needed the resistance, that would be the voltage over the current. In this case, we know that the voltage is 5 volts, and let me give you a resistance. Let's say the resistance is 10 ohms. So we know we need to find the current I, so the current I is going to be the voltage over the resistance, and the voltage is equal to 5 volts. The resistance is 10 ohms. And if we do that, that would be 0.5 amps. 0.5 amps. The value or current is represented in amps. Amps, that's short for amperes. So in order to calculate or figure the voltage, current, and resistance, those are the 3 key things we need. If we have any 2, we can figure the third. So definitely remember, and you definitely will need to know, the voltage equals current times resistance and all of the different iterations of that. The other equation that we need is sometimes the power equation. And the power equation, P is equal to IV, and if we needed to solve it, we can solve that in terms of if we had the current and the resistance, and that would be that power is equal to I squared times R, and you'll hear that a lot, and you could solve for any of those knowing these equations. In this case, since we know the current and the voltage, we found the current as 0.5 amps, the voltage was 5 volts, we would take the 0.5 and multiply it by 5, and that would give us 2.5 watts, and power, its unit is a watt. Okay. Well, thank you for watching this Dan on Tech video, and please subscribe to this playlist so you don't miss any of the future videos. Also, check out and subscribe our other playlists on the Dan on Tech channel.